This question seems like a lot, but in actual fact, it's down to one formula you need to know and basic math. So let's draw a little sketch to make it easier to understand. Now disregard the screen height and trees for a minute. We initially need to focus on how high the plane will climb with the given factors. Therefore, we need to apply the formula for height difference in wind conditions. So we have the ground distance of 250 meters. We will now multiply this by the ratio of our true airspeed of 60 knots divided by our ground speed. With the headwind of 10 knots, our ground speed will be 50 knots. Now this ratio will easily allow us to determine the air distance in given wind conditions. A true airspeed to ground speed ratio greater than 1 means headwind, and a ratio smaller than 1 indicates a tailwind. Now in our case, this will give us 300 meters. But what are those 300? They stand for air distance flown in meters. Now remember, we had 10 knots headwind, meaning we've flown 50 meters more through the air due to the headwind compared to the distance over ground. Now we multiply the 300 meters times the 9% gradient. Because the gradient is given in percent, we need to divide the gradient by 100, which equals 0.09, times our 300 meters equals 27 meters of height. Okay, first step achieved.
Now let's bring in the screen height and the trees again. The 50 feet screen height equals 15 meters, so we effectively climbed to 42 meters. And the question asks, how high are we above the trees? So we subtract the 8 meters and bam, 34 meters is the solution.
34 meters is the correct answer. We hope this didn't go too fast. The key thing here is that you need to know the formula for the height difference and to read the question carefully and not forget about the initial 50 feet. Practice makes perfect, and if you want to practice more, get full access to all the questions on the ATPLQ database with this link. Yeah, buddy!